everybody, my name is Haim and I'm a business development manager at CloudZone. Welcome to our webinar, Get More Value from Snowflake with Upsolver. Together with me is Iftach Schonbaum, our head of innovation, which is going to tell you all about that. Again, thank you for coming and I hope you guys enjoy. So let's go over today's agenda. I'm going to start with a short intro on CloudZone, and right after me, as I said, Iftach is going to take over and tell you all about how to get more value from Snowflake with using Upsolver. And that's me, and there you go. So, CloudZone. As I'm sure some of you already know us, CloudZone is the leading multi-cloud solution provider and professional service provider in Israel. We are a premier partner of AWS, gold partner of Microsoft Azure, and premier partner of Google Cloud Platform. We run consolidated accounts for our customers, and we deliver all types and sizes of cross-sector projects. It can be a startup, it can be an enterprise, or anything in between. You'll find us there. Delivering projects in any size and in any vertical, as you'll see in 2 slides from here. We are also, of course, a subsidiary of Matrix, which is the Israel's leading IT company and the biggest company in Israel, with more than 10,000 employees spread across several divisions with high expertise in fields like finance, data analysis, web and application development, DevOps, and of course infrastructure, all its pillars, which entitles you from CloudZone to receive the umbrella of solutions that you require within each one of your projects or your cloud journey. So what our expertise are? This is our competencies, at least in AWS. And we're also chosen as a DevOps Partner of the Year for 2020. So you can see from the list of competencies, we're ready to deliver any type of cloud-related projects to you. And this is what I started to say earlier. This is our competencies. So starting from cloud migration, which is our main business, you might say, and going through machine learning and IoT. Well, basically any buzzword any new buzzword in our market in the cloud world, we love to be the first one to be able to deliver a complete end-to-end project and to address any of your requirements. We provide professional cloud projects in any area of desire, and we hold competencies which allow us to deliver according to regulation requirements. And as I said, in a variety of industry sectors. And I'm going to complete my intro with actually this very important slide for me. So this is our core services, which means each of you, our customers, receives and entitles to those core services only by becoming our customer and consolidate his account with us. So first, starting from technical consultancy, our team of really senior and certified solutions architects are ready to provide ongoing professional consulting and advice through any channel you may choose. It can be in a wide range of topics. It can be cost-oriented cloud infrastructure. It can be big data analysis, application modernization. It can be, of course, security, DevOps, machine learning operation, migration, of course, and cost-oriented design, and basically any things you want to ask and advise with our professional teams which relates to your cloud journey. We are here for you, and you're entitled to our presence. The second core service I would mention is the technical support, which is CloudZone's top-notch customer support team, covers critical workflows and technologies, and is available as a third-tier support through business hours. And under the CloudZone consolidated service, you get AWS business support, you get production level support benefit by GCP, and you get the partner premium support benefits by Azure. And for all those, CloudZone provides the first-tier support. And the last two core services, and the first one is the FinOps service. Our FinOps teams proactively works to ensure customers manage their account in an optimized manner, taking advantage of the savings mechanisms available in the marketplace. The team monitors customers' accounts to proactively prevent any cost anomalies. And in addition, it provides cost savings documentation or ongoing regular cadence. I would like to say that basically we monitor your cloud in the cloud services, in the AWS, let's call it that way, in the AWS services level, which means we detect any type of anomalies or misuse or of course unplanned peak consumption, and we make sure you're familiar with it and you know what to do next in order to avoid or to expand it if you need. And the last one is the financial visibility analysis tool. CloudZone provides our customers with access to an in-depth cloud financial analysis slice and dice solutions, which runs by Cloudel via VMware. And this solution enables comprehensive visibility into all cost aspects, as well as deep analysis capabilities. And this solution is being utilized both by you, our customers, and by us, by CloudZone, by our lovely FinOps department. And I think this is a good opportunity to pass it on to Iftach. And I want to thank you again for listening to me. And hope to see you again and very soon. Thank you, guys.
Thank you, Haim. Hi, everybody. My name is Iftach. I'm currently the head of innovation in CloudZone. I've been working for CloudZone for the past 4 years, and let's begin. So today we're going to talk about how to get more of Snowflake with Upsolver. So I guess some of the people attending are Snowflake customers and are already using Snowflakes, or maybe plan to use Snowflake. But even if you're not using Snowflake, you can gain lots of insights today. And in the heart of the talk is Upsolver, the Open Data Lakehouse engine. And the agenda will be a short intro to Snowflake. Then we will enter Upsolver and discuss what Upsolver is in general and what it can offer you. And then the advantages of using Upsolver with Snowflake. So Snowflake is a popular modern cloud data warehouse. It was founded in 2012, and it's built for the cloud. It was born for the cloud, meaning it's leveraging all kind of the cloud native approaches, like one of the top ones are of course the decoupling of compute and storage. It's an AWS technology partner. It's very strong and very powerful with exploring and querying semi-structured data and data from many shapes. It's serverless with, I would say, zero maintenance or really low maintenance. It offers instant scaling, which means it can scale really fast. And has a high concurrency, and it has many features also which are for the enterprise, and one of them is their focus on data collaboration and how they can maximize values from siloed data. And it has all kinds of tiers, which I'll discuss shortly, and the more you go to the higher tiers, or the more expensive tiers, the more features you get and more towards enterprise features. It offers several flavors as discussed. So you begin with a standard, which it's where you get the majority of the features, really a lot of features. You get a lot with the standard. And the more you go to the right, you get more features for durability, high availability, being compliant to all kinds of compliances. You can get already from enterprise security features like dynamic data masking and tokenization, which is very cool. And of course, the more you go right, you pay more. And that's quite it. I can say that we have many customers that are using Snowflake. on AWS. They are like mostly very happy. But today we will discuss how we can get even more from Snowflake. And right now, just let's jump over to discuss Upsolver, which is the focus of the talk today. So Upsolver is an open data lakehouse engine that reduces engineering overhead dramatically. So in a purpose, I read the sentence as it is because it's really what it is. So the concept of open data lakehouse, which we'll discuss shortly, it's a concept where basically you are decoupling the processing and the processing of data and keeping it around the lake, and around that you actually build your databases and query engines. So in the heart of this data platform, you will have the open lake, open because it's a data lake with data processing, and around it you can just use many targets, databases, query engines, as said, and it's kind of the reason why it's open. This product is founded by Upsolver originally to kind of tackle all kinds of issues and frustrations that many organizations had, and they kind of created this beautiful product to tackle many of these things around data lake. They have many investors from this very same ecosystem, which means a lot. Snowflake is one of them. It's adopted by data-driven enterprises and startup, so we can understand from that they can actually be event-driven, like the same way like you would maybe think about Flink or some other open source tools. And it's an advanced technology partner for AWS for 3 years now. So before really talking about the features and capabilities, what is the value of Upsolver as I see it? So first of all, it's democratizing the data lake in a way that it's very easy to kind of enjoy and instantiate and set up a whole platform around the data lake where you can easily with SQL do many complex data engineering tasks. It improves performance in the data lake with many capabilities and embedded best practices they have inside. So it's things that you would maybe as a very advanced data engineer would do yourself, maybe with Spark, but it would be very hard, and it's really not covering all of that, what Upsolver can give you. It's making the data lake more rich in the way that it can of use cases. Like it unlocks more use cases for the data lake with all kinds of additional features that they can give on top, and we will see them today. It's empowering analysts to really easily, with SQL, perform really complex data engineering tasks. So when we say complex engineering tasks, I relate to things like blending real-time streams, doing lookups in a very high speed to enrich all kind of messages that are flowing through the stream and so on, and you can do many things of this with just simple SQL statements or from a really nice UI. As said, it decouples all the data processing from the warehouse. So we will discuss it today. So sometimes we see really an organization doing the ELT or the transformation or the processing or the aggregation within the warehouse. Sometimes it's a good practice, but many times it's not. And this decoupling also boosts or making the platform very agnostic to the query engine or database you want your data in, right? Because you're doing all of this in this open data lake, all this processing, all this creation of data assets, and then you just ship it to wherever you want. So this decoupling is very powerful. And as I said, it unlocks all kinds of use cases for the data lake itself. and we will see some of them today. And as said, it significantly reduced data engineering barriers, which yields immediate ROI. You don't need to spend a long time on acquiring skills of some open source tools in this rich ecosystem of big data. And the main features, and I also want to show you a bit on the screen. So in general, Upsolver lets you connect to a variety of streaming and batch sources. So it can be Kinesis, it can be S3, it can be Kafka, it can connect to all kinds of like relational databases and warehouses. They have a very strong schema on read capabilities, and they really makes it very easy and seamlessly for you as a user to kind of change the shapes of the data, or modify it, add columns, add fields, and if it's nested or not, and so on. And they really do the heavy work for you, which is a very, very important and a very good capability, and gives a lot of value there and agility. So as discussed, also data transformation can be defined through a very simple UI or SQL, which is super great. It really makes scientists and analysts to really kind of self-service create their own data assets when they need it. And when Upsolver is really paired with a warehouse, you really get the best of both together, and what you actually get is kind of a data platform where you can do many things. All the data that flows through Upsolver is maintained for you in its original shape, or the raw data, I mean, of course, on the data lake, on S3 in AWS. And is doing all the processing there before it's promoted to the warehouse, right? So it's kind of the best practice where you have the tiers and of the quality of data, where you want your data in the warehouse to be the most curated data and in the least amount of size, of course. So the warehouse will not become kind of a swamp. They have lookup tables, which is a super powerful feature and capability not talked about enough, and these lookup tables we will discuss more about in the upcoming slides. But in general, it's a lookup, it's a key value store where it can be powered by the streams that flow through Upsolver, or they are powered by some streaming sources like Kafka, and they can serve these keys and their values with in a very high scale with under 1 millisecond latency, which is very important for many use cases like machine learning and user store, and we will see even more in today's talk. And it can run on spot instances seamlessly for you. You're not really dealing with any of the stuff, and so it makes the compute workloads very cost effective. So just to illustrate, what is the concept of the open data lakehouse? So you have traditionally you can do the data processing within the data warehouse. So yeah, you can do it with simple SQL, which is nice, which is good, but it will be most expensive on when it's done in the warehouse, right? Not always batch only. For example, with Snowflake, you do have the concepts of streams within Snowflake, and you kind of drive a stream of changes from one table to another and do some streaming use cases, but it's really not that easy, and mostly it's for CDC based. And because you have all your data in your warehouse, you have some engine lock-in, right? You need the data in some other place, right? Because if the raw data is in your warehouse and you want now to kind of ship it to some other database with other capabilities for other use cases or application, you would need to kind of start take it out from Snowflake, and it's not something like which you would want to do rapidly or often. Then you have the other option where you kind of offload all this data processing, but then you will need to do it with coding, and the ecosystem is, of course, complex. It's very big. Not all of our organization has these skilled data engineers that know Spark or Flink and can write and implement stream application, real-time stream applications like stream analytics or event-driven application and so on, you get more value, right? Because you get more cost-effective compute. You can implement stream and batch. You don't have a query lock-in, but you have a very, very complex and heavy tasks to cope with, right? So a lot of big solutions or big let's say platforms built on top of this in some organizations can sometimes take a month to instantiate, but with Upsolver you can really do this these huge tasks or projects really within days or weeks, which is very impressive, and I've seen it in my eyes, and it's really impressive, and I really love that product. So with Upsolver, you get best of all. You are doing all the processing and the creation of data assets on top of the data lake. You do it with Upsolver, you get all of the best practices embedded inside. You do it with simple SQL, you get cost-effective compute, yeah, and you enjoy this decoupling from the targets or the databases or query engines where you want your data, and there is no lock-in, right? You can take an asset you send somewhere, you create it, and you can just duplicate it and just choose another destination, and you will have the same lineage and the same result. So just to kind of, before we go on, I want to kind of show some of the basics. We are not going to see all of the capabilities today of Upsolver and all the screens, but I do want you to get the idea of how this product looks like and how you define things. So as I explained, so the main idea is that you have sources where you define where you take data from. So again, it can be all kinds of things. It can be stream sources, it can be batch sources, really a lot of rich things. You can see mainly things from AWS, because initially Upsolver was exclusive on AWS and was operating mainly on AWS. And as you can see, I have already some sources defined. In this example, I have some data set in S3, which is a batch source, and I have two Kinesis sources. And in that case, it's like impressions and the clicks for the impressions. In this demo and environment, I'm kind of the one generating the impressions and the clicks in some, as opposed to the real world, it's kind of generating random data, but in a logic that would create some matching between impressions and clicks. I would start now to kind of ship the data, right? Hopefully it will not stack all my program, because I'm also recording and also really ripping my computer. Okay, so I'm sending now traffic to both of these Kinesis stream, and it will be visible here in no time. As you can see, all these spikes, it's because of my games, and I stop this streaming and I do it again and so on. Yeah, so in the last 30 minutes there was no sending of traffic, so it would show really soon here on the screen. Once I have a source, as I said, like Upsolver maintains the data that flows through this source, the raw data on S3 for you. So immediately you get like a raw data management, really out of the box seamlessly. It's very cool. The next thing you would do, you would create an output, and all of the processing and the aggregation or whatever you do, whatever asset you want to create, a data asset you want to create, you do it through the output, right? So as you see, I have a few outputs here. I have output to Athena, and I have outputs already to Snowflake. And I would, for example, I have an output here to Snowflake, which creates me like the click-through rates for my campaigns, right? So I have these impressions and clicks flowing in the system, and I send the Snowflake only the output, right? So if I will show you the definition, I like and used to define the assets in SQL because I'm already used to it here, but you can do everything from the UI. It's a very nice UI. So the definition in the UI looks like this. And while you are building your assets, you can see many statistics on your data, which makes it very easy to kind of build your process, build your asset. But let's not dig into it right now. Let's just see that I have quite a simple SQL, which is doing quite a powerful thing. What this SQL is doing is actually merging or joining two streams. These two kinesis stream, right? I can see them on the left. And I'm taking from imp clicks, right? So imp clicks would be that source. Let's go again. So I'm extracting some data from the click stream and also from the impressions, and I'm joining between them. But not only that I'm joining between them, I'm instructing for the impression, and really don't try to understand now the SQL, it doesn't really matter like right now, but what I'm doing, I'm actually telling here the impressions stream to wait 1 minute for the click stream, right? So like in real life I would wait more, but what I'm trying to say here that this SQL, what it does, it actually instructs Upsolver, so before it will start join data between them, I want to kind of wait for the clicks data. I want to give enough time for the clicks data that fits the impressions that comes usually earlier to be able to find a match between each other. So I'm kind of creating a delay between the streams. But once this delay is over, they're kind of moving together, like with a sliding window, right? So that's quite powerful. And then when I have this match, and of course I'm matching between them, I can actually see, I can connect the clicks and see the click-through rate. And this is actually sent to Snowflake. So before I show Snowflake, let's just see that the stream started to work. So let's look at the last 10 minutes. Okay. So we can see we can see here, I mean sources, yeah? Like you can still see it here because these outputs are fed by these sources where I'm sending data to. But it's better to see it on the sources. And if I'm looking on the last 10 minutes, of course I can see the data starts flowing, and once it flows in here through this output, it goes into Snowflake. So in Snowflake, I can already see, like if I would just preview this data, I didn't mean that. I meant to do the query for the click-through. Let's just do that. I was sure I had this I had this somewhere. Yeah, okay, never mind. Wait, I might have this. Yeah. Okay, it seems like it is this. All right, cool. So what I get here is the click-through rate for all my campaigns updated in live, but I didn't do actually anything within Snowflake, right? I just created this powerful asset. Yeah, again, it's joining between streams, doing it in real time with a delay between the streams, and at the end I get the result in Snowflake. Okay, now that we understand the tip of the iceberg of what Snowflake, how Snowflake looks like, let's discuss how Upsolver completes and increases the value of Snowflake. So first of all, we're talking about cost. So that's the main impact where Upsolver can give you here. And as discussed, data processing would be most likely more expensive or most expensive when it's done in the warehouse, right? Like if I will take all of my raw data and I will put it in Snowflake, right? And I will do and create assets there. I would utilize more and more credits, which in turn might be a big spend. And Snowflake is really good. Really, it's an amazing product. It's really good in querying data. But the more I just give him to query data, the more value I get from it, right? Because if I am putting all the raw data in Snowflake, right? So I would process it there. I would also most likely keep the more curated data also there, and in historical manner. And again, this causes more utilization of more credits, and also it means less idle time of warehouses, and it will require more like a bigger warehouse size, right? It would not be most likely extra small. It would turn into bigger warehouse sizes. And also I want to kind of follow the best practice of data quality stages, right? I want the raw data, of course, to be on a cheap storage, but in the ability to still query it in a cheap way, right? So I would want the raw data to be on S3. I would want maybe a silver data also maybe on S3 in many cases, right? If it's for machine learning data assets and so on, I might want it there, right? And at the end, this 10%, or that's what we see usually, like where in organizations that keep this best practice, this 10% would be in Snowflake, right? So I would keep the list of data and the most curated data and finalized data within Snowflake ready to query. But then I would use much less of query processing or aggregation or data processing in general within Snowflake. On top of that, Upsolver also optimizes data as it places it on the lake, which means that even there it would reduce the costs and increase the performance. And if in case you are, for example, working with external tables or you're querying data with Snowflake on top of S3, this best practices applies, right? So if Upsolver would keep you the partitioning and which, okay, partitioning you would say like, okay, in Spark, I would just partition by and push these Parquet files to S3, but Upsolver is doing much more than that. And among the things it's doing you seamlessly compacting your data. So if you have data flowing inside in a stream, it would in many cases create many small files, and then you would want to compact them, right? Because you want maybe 128 megabytes per base Parquet file for Athena or some other query engines to really maximize the performance. But compaction is something that is not easy to do, right? So you have all kinds of very modern tools that might do that for you, but it's hard. It's very hard to do with Spark. And when I say hard, I don't mean that it's really hard, like to write this code that examine the files, the size files, taking them in as a data frame, and again push them inside. It's maybe something that is doable, but it's very hard to maintain anyway. So so they do all kind of best practices, which also applies for external tables of Snowflake the same way it applies to Athena, for example, to query this data. And also with the powerful lookup tables, and I will show it in short, you can really do very powerful stuff. So let's see it, right? So I've prepared here something. So what the lookup table is, as discussed, is it's something that can really be fed by the stream, right? So if I will go to the definition of this lookup table, I could see that it's fed by the impression table, right? What I would try to make it easier, but for you to see. But I've also defined this as SQL. But again, don't try to understand SQL. Maybe later on, because this SQL is kind of a standard ANSI SQL, but with more extended dialect to add Upsolver capabilities here. But in general, what am I doing here? So imagine that the clicks, the impressions stream contains all kinds of data about the impression, right? So one of the things, it would be like the device OS, right? So if I will click here on the device OS, I can see a lot of statistics on the data, right? It can give me a lot of insights about the data, about the density and how much, on the presence of each value in the stream. It's very powerful. And the way I generated, for this example, I generated data. Maybe it's not a good idea to show the Java, but what I'm actually doing, I'm creating some the logic where I have three main device OS, like I have Android, iOS, iPad OS, and you can see that they have a very dominant presence in the stream, and the rest are very small fractions, right? So what I want to do here, I created this in a purpose in this distribution, but in real-time examples, it's quite the same, right? You have a very dominant, let's say, device OS or I don't know, country, but then you have a very long tail of things that they are just really small fractions of the stream, right? And if I would treat this as keys, every single value here as keys, I might get an explosion of data in the warehouse, right? Because if I want to give the ability to really slice and dice according to these keys, in many cases, this would create a very, very big data sets. So what I can do with, so you can see that, right? So every value here, which I generated, really I'm generating this randomly, is very, like you can say, like you can see it, right? So it's really a fraction of a percent, a really small fraction of a percent. So what I can do with the lookup table, I can say, your source is this impression stream. Is this impression stream, and what I want to do, I want to kind of count per device the amount of times it appears, right? And kind of divide it by the total of the devices I see, or total of the total messages, right? And then I can get this fraction where I just sent you, where I just showed you, where it actually works the same, but this is like internal lookup tables that are powering Upsolver. So I'm kind of doing the same, just as an example. And then what I can do is I can use the output, during the output, do a lookup, right, with the device OS, right, of the message, and just check the value with the lookup table, right? So let's look at the lookup table of how it looks like a data sample, right? So I can see all of the values here. So imagine that during the stream's flows to Snowflake, it would, per message, look at the value of this this key, this device OS, and if it's below some threshold, let's say, I don't know, like one tenth of a percentage, I would just turn its value to other, right, to some general category, and then I would significantly reduce the amount of data I'm sending to Snowflake. And I can do that in real time. And moreover, right? Moreover, I can do that in a specific time window, right? In a specific sliding window. So I can say I want the lookup table to calculate, right? And you've seen it in the SQL. You see this window of 3 minutes. Again, in real time, in real life example, it would be maybe 24 hours because I want to kind of calculate the relevancy of this device OS in this example according to the last 24 hours. But just here for an example, I did it like a 3 minutes. But imagine that I can do this. Lookup tables can calculate this over a sliding window, right? So every sliding window of 3 minutes will calculate you the relevancy of this device OS, and then in the output, I can really check it out, right? And this is just one example. Imagine the things you can do with it, right? Yeah. So, and as discussed, these lookup tables can also be exposed outside, right? Not just for internal data assets you build here. It can really just be a key value store exposed outside, where you can serve all kind of stuff that are calculated from the stream in real time. Okay. So this as well can reduce cost and really, especially in this kind of like a real-time bidding use cases where you have many long tails of all kinds of really insignificant keys. The second thing would be managing raw data and historical data. So Upsolver makes it very easy to kind of manage the data in the data lake, right? So first of all, it maintains all the raw data for you, right? Every data that flows inside will be kept on S3 for you, which is that. And you can say again, okay, I can do that. That's not a problem to kind of keep everything. I can send things to Kinesis Firehose, and the things will stay in S3 and so on. But when you're starting to do it with many sources and stuff, it's kind of becoming more like a swamp more than you are really managing raw data, right? Because when you have this coupling between what is a source to the data that flows in, it would be really much more easier to manage it. Upsolver also makes it very easy to kind of recompute things or duplicate assets and change them a bit, and to tell this asset, I want you to start from this beginning point of time, since Upsolver is maintaining all of the raw data for you, right? So it can really, and it maintains it in the way it's doing it, with best practices and partitions and so on. It can easily also replay or create assets from point in time or from the beginning of time and so on. And it's really, all of these things are with just a few clicks, or sometimes even one click. It's quite amazing. So for example, I can say, for example, that the output for the click-through rate, I might did a mistake, or I want to kind of, include another fields inside, right? So let's maybe first, just for the example, I will also change the data I'm sending in, and we can also see how Upsolver is being updated with this data. So for example, I would just like stop this. Let's just add here some thing. Okay, let's call it, I don't know, some int, and generate an int, right? By the time when it's running, yeah, I think I did a mistake. I had to run. This is the impression data, never mind, it's the same jar, so just a second. Okay, so this flows now messages with additional field. But what I can do now, look, let's finish the slide, and then I will come back when I have the field. It will take just 1 minute. Yeah, sorry for that. Okay, so I will demonstrate that in a moment, but when I have this capability of doing this recomputation like very easily and outside of the warehouse, so again, I'm finishing only with the data asset in the warehouse, in Snowflake, in that matter, and I keep this positive momentum of just having only my curated data in Snowflake, right? Because it's not just it's something that comes also with the practice. The more you practice it, in the long term, you would see the result of you are really decreasing the amount of computation you are using within the warehouse. Also, Snowflake's time travel is limited, so you get for the standard tier you get 1 day. I think at most, yeah, 1 day, and for enterprise and above you get up to 90 days, and sometimes or many times it's just not enough, right? So you will need to go back to your raw data and create a new asset or whatever. And again, if your raw data is within Snowflake, then you would again compute this stuff. But because of Upsolver makes it very easy to do it on top of the lake, so you're really enjoying all of the worlds, right? You can do it on the lake. You can do it in a low cost on the lake, and you keep all the data processing outside of the warehouse, and you get also the benefits of the lock-in and so on. So it's kind of a really harmony of advantages. And also sometimes when you will want to take a very large amounts of data out of Snowflake, let's say you kept your raw data there and you wanna take it out. So sometimes it can be tricky, it can be faulty, and it's not all the time goes really smoothly. And it's just much easier to just go to an output, duplicate it, and change the destination, right? Or do some modification. So we added the some int, right, field, so I guess I already see it here, so I just want to demonstrate the way that they are really dealing with, so it's already here. I'm already seeing messages, I already have statistics about this, it's amazing, right? So this is how the Upsolver copes with you know, the schema evolution so easy, right? So now I already have this in the output, I can already relate to this in the outputs, I mean in the source, and I can already relate to that new fields in the output, and now, for example, let's say I have some asset, I want to create a new asset that includes this field, but I want to kind of recompute it from the beginning. So all I would do, for example, I would maybe edit this, not edit, let's just duplicate for now, just because we want to do something else with it. Let's discard this draft. So I would just not edit it, I would just duplicate it, right? We call it, I don't know, my new CTR, yeah? Yeah, my new CTR. I would tell him, I don't want an existing table, I want a new table. It's being fed right from the impressions source. And then I can already see here, I should be already see here, the some int value, and I can already relate to it. So I would do it in SQL, because it's much easier. And I will also select some int, right? So I also already get, you know, I also get a very nice IntelliSense here to work with the stuff. Yeah, just a second. Yeah, I would just add it here. Okay, let's see. And by the way, every time I edit something in the UI or in the SQL, the changes are kept, right? So the translation between the SQL and the UI is being done for you as long as the SQL compiles properly. Yeah, let's say I would want it here. Yeah, so that's all I did, right? I created a new asset. What now? Oh yeah, of course. Okay. I can also preview the data. I can already see it. Yeah. and I can just run it, right? So I just duplicate it, change the bit to SQL, and run it again. And now when I run it, I can, of course, put it into new table, as discussed. Right, so I also, for the curated data and the way this asset is built, I can also, Upsolver also can keep this data on S3 if you want. And that's it. And now I can enjoy what Upsolver is giving me. Is a very easy way to recompute this asset from the beginning of the source, like imagine the beginning of the stream, right? So Kinesis is limited in any other managed streaming service or stream ingestion service. It would give you some retention, but it would never be too long, right? It would be, I don't know, a few days or something like that. But because Upsolver would take this data from the source, from the real source, and as part of their source entity would keep this raw data on S3, I can always very easily compute this asset from the historical data from the beginning, from any point in time, or from now, right? So just for now, for the example, let's do it from now, and let's deploy it. Right? So I created a new asset. I enjoyed like the schema on read or the schema evolution. I chose very easily from where I want to recompute this stuff, this new asset, and I just did it with a few clicks, right? So this would start to work, and we'll start to push the data into Snowflake. Let's talk about stream aggregation and stateful aggregation, right? So today, like batch is not enough, and everything is being done in stream. So some organizations would have a very super skilled, very skilled data engineer that would write you some Flink, maybe a real-time application like a stream analytics or event-driven application with Flink, and maybe they would do it amazing, but it can take a really, really long time. It's very complex. So first of all, again, if you stream your raw data directly into Snowflake, so again, you will maintain this table inside. You will do maybe truncations, maybe because it's raw data, maybe because of your raw data is within Snowflake, right? And you are sometimes creating from this raw data all kinds of data assets. You would want these data assets to be created very fast or being queried fast. So you would cluster the table, right? But then you have additional costs. That depends on, I don't know, the data volume can be so high that this cost can be significant. So, for example, when you have a clustered table, their maintenance, you're being charged for it, right? So you can see it in the usage under automatic clustering warehouse, right? So you can see your warehouses and then this warehouse. Or you would do it outside, right? Outside Snowflake, but then you would do it with I mean, the other option is not where you stream your data directly, so this bullet should be on its own, but if you would do it outside, still you would invest a lot of effort in building these stream aggregations. So doing aggregation is much easier outside the warehouse, like aggregations on streams, but doing stateful aggregations, it's impossible within the warehouse. Like, I don't know a warehouse that is doing a stateful aggregation. So stateful aggregation would be, for example, this sliding window, like looking at the stream in a windows of, I don't know, 3 minutes in an interval, but when the gap between them would be, I don't know, 5 seconds. So you just examine these windows. This has to have state, right? You cannot just do it without state. And again, with Upsolver, it's very easy. We saw it with just a simple SQL. I can do really a stateful aggregation, right? And I can get the result of this stateful aggregation in Snowflake, right? So I'm really offloading a lot of effort in time, and I can do also things that sometimes are impossible. So lookup tables, just to cover again what the lookup table is. So that's actually one of the most powerful features of Upsolver. So imagine that again, you saw all the statistics, everything, all this entire platform is being powered also by this lookup tables, and the patent is, the amazing patent here is that this data can be queried, compressed in memory, right? So and also the data of the lookup tables is flashed to S3, right? So the size, actually, you can keep a very, very large size of data served by the lookup tables. It's very fast, right? So as I said, percentile 99 is under 1 millisecond. It's quite amazing. Yeah, that's enough. Let's not cover more than that. So another thing you can that you can might enjoy Upsolver, right? So material views cost money, right? I'm not sure how much money, but they cost money because when you have a materialized view and you add more data, I mean, I'm talking about materialized view within Snowflake. So you would update the base tables with data, and the minute you update data within the materialized view, you will see. I can show you this. You would see that you're just a second. Yeah. Okay, so you would see, I didn't do a lot of stuff here. I just wanted it to pop out here. So you are being charged. It's one of the serverless features by Upsolver. By Snowflake, where you're being charged, right? So if I would have a lot of data, or data which is close to the original shape, right, before aggregations, before any aggregation, I would expect these credits to accumulate, right, and it can become more and more by the time. And I can spare it, right? If I'm doing the aggregation before that, right, and I'm shipping aggregated data, let's say still in a real-time manner, right? It would not be like very aggregated, but it would be still very aggregated in some use cases, even if the window it would be 1 minute, right? And then maybe I still want to use materialized view, but I would the maintenance would be lower, right? Also, materialized views are limited in Snowflake, not just in Snowflake, but they have limitations, right? So you cannot do many aggregation functions. You also can define a materialized view only within a single table, so you cannot really perform joins. Like the view cannot contain definitions of joins or self-joins. Also, you cannot do some stateful functions like window functions and so on. But all of this you can do really easy with Upsolver, right? So because of the powerful state you get with lookup tables, you can do really great stateful aggregations as we discussed, and still get the results, the curated results in Upsolver, in Snowflake, right? So that's also one of the benefits you can have from Snowflake with Upsolver. And the last thing would be machine learning, right? So what you can do actually with Upsolver, lookup tables again, you can actually, not just with the lookup tables, like with Upsolver, what you can do is, just a second, okay. So let's discuss first about the feature store, right? So for the ones who don't know what a feature store is, so very briefly, when you want to, of course, build a data set that would in turn be fed into for training into a machine learning model, there is the part where data scientists sometimes is the data scientist, right? It's not good when it is the data scientist, but I actually need to create the features, right? The data that is being fed into the machine learning, right? And a good feature store would be one that has a unified way for calculating this feature store, both for the development, so what we call offline for training, right, and online, right? So imagine that you use the features first of all to train the machine learning, okay? But many times this very same or a subset of these features, usually the subset, would then be, you will really need them, for example, like a user profile or anything like that. You would need them to enrich in real time the prediction requests, right? So what Upsolver can do, because it has this kind of a way of duplicating the assets and has the same lineage or the same computation, but one will feed, for example, a SageMaker directly, because Upsolver can has integration with SageMaker, but also with S3, it doesn't matter. But it can easily create this with an output in Upsolver, create this data set, but then in the same way it can power a lookup table, right? And then I would have both. I would have this good feature store or a great feature store where I have the same features, right? Both for the offline and both for the online environments, right? And usually a feature store for the online part needs the very same capabilities that a lookup table in Upsolver has, which is serving key value requests in high scale with very very fast response time, right? Like under 1 millisecond, because I want to kind of do it per message I see on the stream. And what's great, even more than that this when I do it with Upsolver, because I have this all kind of capabilities of doing it on top of streams, I can create this data set or the online feature store. I can create it really easily in a way that it will be both fresh and automatically maintainable, so it would be kept fresh. And I will show you an example in a moment. But that's really amazing, right? So when you would want to do it by your own, you would need a key value, a store, you would need an orchestrator, and you would need the data processing framework. So it can be Cassandra, Airflow, Spark, but again, it's this open source ecosystem where you need to work very hard to build and maintain, and you can kind of get all of this from Upsolver, right? And in machine learning, in the context of Snowflake, so for the ones who don't know, so DataRobot, which is an enterprise AI company, partnered with Snowflake in a very key also investment and partnership, and they will start to kind of I don't know exactly what they offer or will offer, but at the end, this combination, like decision engines or whatever it will be, together with this feature store, which is automatically maintainable and it's very close to the stream in the way it's being built or generated, would create a really awesome value. So I didn't show you I want to show you this example. Yeah. So let's look at this ML dataset. Again, I will show the SQL, but don't try to understand the SQL currently because you will lose focus. But I will just explain what an awesome thing you can do here with Upsolver. So imagine that I'm joining streams. I'm computing two different things from the click stream. So I'm computing click data from the stream and calculating user data. And then what I do, the user data, I'm computing over 90 days. Just like that, just writing window 90 days, I know that this definition of data within this output would accumulate until it reaches 90 days, and then it would become the same sliding windows of 90 days of data, right? So imagine that one of the features of how a user, clicks, like a data scientist decided that it can be related to the amount of click he did during the last 90 days, right? So I can just generate a user data based on 90 days, which I know that at the beginning it will accumulate the statistic until it reaches 90 days, but then it will flow on, right? And then the rest of all I do, like I did in the click-through rate, I just I join the stuff and I say what is a click and why is not, but I also can include now this value of how many clicks it did during these 90 days, right? Now, how is this being done? Like you would say, I need a lookup table for that, right? I need some state that will trace per user this amount of clicks. But for when you in SQL, you are using stuff like in Upsolver, stuff like windowing and so on, you get internally, Upsolver is generating a lookup table for you. So it won't show up here, but it's really powering that state. So really with just this simple SQL, I created a automatic data set, like in the means that it maintains itself. It's being updated all the time with fresh data, like the features. This clicks per 90 days. It's always going to be fresh, right? For this user, for example, for that user. So I just want to see the table name in Snowflake. Yeah. Okay. Yeah. I have just one now. Yeah, so it's this one, right? So I have a query here. Okay, yeah. So I have a data set that is being streamed. So maybe maybe this would be very helpful for tools like that of machine learning that Snowflake would provide. But now, look, I have a data set, right? I have what is a click, right? I have the user. I can, of course, enrich here more with the user profiles or the feature store I would build. And I have, so in the logic I'm generating random users and so on, so it didn't accumulate more. But, for example, look at this. So I have here, in this line, for example, a user that didn't click for some impressions, but together with it, I do have the feature of how many clicks it did during the 90 days, but in related to this time, in related to the impression time, right, or the click time when there is click. So imagine I could add more features that are generated from the user behavior during any time window, and this data set will always be kept fresh and automatically maintained. Super powerful. So, and also I didn't show, I have also an example. I just wanted to show one example of some embedded best practice. So for example, I have here a data set, like I took it from a batch source. Again, it's this source, orders. So I created a source that it's looking on some data on S3, right? And then I created two outputs from it. One with compaction, one without, right? So by default, every new output would be with compaction, okay? That's just one of the best practices the Upsolver is doing for you. But you can see it here, right? Yeah, compactions. So this is a compaction with compaction, and that one without, right? So if I will look, so for this example, I did it to Athena. It was easier for me, but you can of course set it on S3 and kind of, or for example, you can what I didn't do, so I can show it the benefits with Snowflake. I didn't hook up Snowflake with the glue catalog, which is possible, but when I do an output to Athena, so automatically Upsolver is also provisioning the glue catalog objects for me, and you can see these tables here, and also they maintain your schema for you, right? So if I would, for example, I would edit an output. I just want to show you how it looks like. And I would like kind of change something here. Yeah, let's, I don't know, do whatever. Yeah, whatever, I'm not going to apply it. But when I will run this, and I will say alter existing table, what Upsolver would do for me is handle the schema evolution on the data lake, which is very cool. So, for example, I have these two tables, one with compaction and one with not, which I loaded 7 days of data. I just want to show you the difference. So, and this is not a large data set. So imagine that this problem can be much higher. So with compaction, I can see that I have relatively fast response, right? And without compaction, I believe it would take more. Not really a lot, because the data is not a lot. It's not big. The volume is not big, but you can see a constant difference between them, right? And if I would to show the amount of files on S3 that are backing these tables, right? So, for example, with compaction, and it's the same data, of course, right? We are talking about the same data because it's two outputs I created, and one of them I created by just duplicating the other one, checking off the compaction and just running it. That's it. That easy. So there is 119 files for the compacted table, and for the non-compacted table, I have 10,000 files, right? Because it was a stream. It was streaming inside the system, right? Even though it's from a batch source. So that's very cool. So I just wanted to show that because I forgot to show you in the beginning. So just to summarize the things, so we see Upsolver, it's not something they're saying, but we really see the Upsolver as the data fabric around the warehouse, right? So of course they see it the same way, but they call it different. So we see it really as a data fabric around the warehouse, right? The complex network of these data processes and the way they are being generated and the way data is moved from a place to a place. We said that it unlocks the best of the warehouse and the lake together, and you really do it by just deploying Upsolver. You get it just by deploying it. It really simplifies data engineering. It really does. It's cost effective, and it supports really any format and any scale. Yes, I think that's it. I hope you enjoyed and that it was insightful for you. I'm going to stay here now for a few minutes for answering questions, and thank you very much. Okay, thanks everybody for attending. See you next webinar. Bye-bye.